Alright, we're going to start off with our binomial theorem, or the topic on binomial theorem. Some of you have met this before, others have not. It all depends on which course you'll be enrolling in for this to either be a prerequisite or not. Alright, so in essence we can say that this is an optional topic at this point and depends on what your next course option is. Alright, now I want to remind you again that the purpose of these videos are taken from a 2-hour lecture or 1.5 to 2-hour lecture, and what happens is that we have extracted all the spaces in between where we would have paused in the class time and allowed our students to work a particular question or look at something. And so instead, what we have done, or what we ask for you to maximize your benefits from these from these recordings, is that once you've gotten the first 10-15 minutes where we have introduced the topic, given a notation, maybe given a couple examples, and then we start working problems, pause the video at that time and then try to work these questions on your own, and then use the video, press play, use the video and check how correct your answer is, or did you go through and use a different method in some cases. Alright, so let's start off. The first thing that we're going to do is we're going to need some new symbols. So the first new symbol that we will use is this thing is what we call the factorial notation. Right, so the factorial notation, sorry about that, spelling is off, notation, and we will define, or we will say, it looks like n and an exclamation point. It's read as n factorial, right? Okay, and what we have, or it is given as follows, that 0 factorial, so this is defined as 0 factorial is 1, 1 factorial is 1. By the way, let me just say that this number n is a member of the whole number system, and which was 0, 1, 2, etc. And then finally we come to what exactly is n factorial. N factorial is the numbers starting with n decreasing by 1 and continues all the way down until the number 1. So for example, if we have if we had asked you to evaluate, right, so let's look at some examples. If we said, number 1, evaluate 5 factorial. Alright, my first thing that we would do is this. Alright, so if we look at evaluating 5 factorial, we would have, so writing this, we would have 5 times 4 times 3 times 2, getting it all the way down to 1. So decreasing. There are the last factor is 1. There is no negative numbers as we go through. And when we evaluate this, this is nothing more than 120. Alright, so it's not very difficult, this idea of factorials. Let's look at it a little bit in a little bit more detail. Suppose we had let's look at number 2. Suppose I have 7 factorial divided by 5 factorial. So we're just doing some factorial arithmetic if you wish. I could go, the numerator is 7 by 6 by 5 by 4, 3, 2, and 1. And now I'm going to divide by 5 by 4, 3, 2, and 1. Just expanding what the 5 factorial is. Start from the 5 and decrease to 1. Now as I go through, you might notice that all of this 5, 4, 3, 2, 1, they appear in both the numerator and denominator, so we could cancel them. So the result is simply 7 times 6, which is 42. Right? Now, can we do this in a shorter way? So, as we go through mathematics, as you've probably learned or seen, what I've been pushing for is looking at more efficient ways of doing our math. So when we go back to this problem of 7 factorial over 5 factorial, I could say this is 7 times 6. And based on what I just saw in the in the earlier problem, right? So based on what we saw over here, right, we can write that the numerator was just 7 by 6 by 5 factorial. That is, I peeled off as many numbers as I needed in order to now get my cancellation of 5 factorials canceling and ending up with that result, 7 by 6, which is 42. Alright, so let's take a minute and just go back to this definition of our factorial and expand on it a bit more. Right? So, let's say, looking further at the factorials. So let's look at it with this example. I could have written that 7 factorial is 7, well, if we wrote it out, 6, 5, 4, 3, 2, and 1. However, if I look at this as just, oops, let's do this. If I look at this, so we could look at it in a different way as 7 times 6 factorial. So I peeled off a single digit, and then everything that's left would be ordered and decreasing by 1. Likewise, I could have picked off or peeled off 2 numbers and had 5 factorial. And considering in the, continuing rather in that same pattern, I could continue and write 7 by 6 by 5 and 4 factorial. Why am I doing this? Alright, let's go back to our more general factorial. N factorial by definition was n minus 1, n minus 2, and we multiply all the way down to 3 times 2 times 1. So in looking at n factorial, we could write it as n and n minus 1 factorial, or n peeling off 2 digits and then continuing n minus 2 factorial, and so on. Right? And this will prove to be useful when we start doing divisions. So given the, let's look back at this. So if I have 7 factorial over 5 factorial, we said it was 7 by 6 by 5 factorial over 5 factorial. In the same way, if I had n factorial divided by, say, n minus 2 factorial, right? So if I had n was 7 and 7 minus 2 is 5, this is an exact setup. These are exactly the same kind of thing. So peeling off just what I need, n The next term would be n minus 1 and n minus 2 factorial, since I ended there, over n minus 2 factorial. Then what we would end up with those canceling. I get final answer as just a product of terms, which will lead to some sort of polynomial, in this case some quadratic. All right. Okay. So let's continue and okay. All right. So let's look a little bit more at some cancellations and some arithmetic using these factorials. So with specific numbers rather than so 10 factorial over 7 factorial. What would we get? This would be 10 times 9 by 8. I can go all the way down to 7 factorial. The 7 factorial here will cancel, and so I end up with 10 by 9 by 8. 10 by 9, 90. We'd end up with 720. Alright, let's get a little bit more interesting now. Suppose we have a few more items. So let's see, which question did I have. So example 2, which we've exhausted a bit. So this was number 2 continued. And then we had number 3. Alright, so continuing, let's look and let's make the problem a little bit more interesting as we go on. So starting off, let's again say that we had 10 factorial. And this time I want to divide by, say, 4 factorial, 2 sets of factorials. Alright, in doing this and expanding the numerator, which has the larger factorial, right, I can peel off as many of the numbers as I can until I get to the larger of the two denominators. So 10, 9, 8, 7, and 6 factorial. This would be good so that I could cancel the 6 factorial on the denominator. Now let me look at this 4 factorial. I could write it as 4, 3, 2, and 1. What am I going to do next? Well, let's cancel common terms. And it actually is now really nice. Don't just go through and look at this and start multiplying numerator and denominators. Whenever anything can cancel, go ahead and do that. So 4 by 2 is 8. That cancelled. 3 into itself is 1. 3 into 9 is 3. So multiplying the numerators, I end up with 10 by 3 by 7, which is rather easy to calculate, and we get 210. Alright, so we're going to give you a couple exercises to do. I will, as I mentioned before in our video, what we typically do is we will, in the class time, give you some time to try these questions in between, and but for putting them up, whether on YouTube or some other site, we will usually compact them. Alright. So here's the first one, 6 factorial over 4 factorial, 2 factorial. Think about it and then let me know what you arrive at. Okay, so continuing now, we have the larger factorial on the denominator is my 4 factorial. So I am going to just extend or peel off enough digits in the numerator to end with the larger factorial of 4 factorial, and then the denominator will expand this 2 factorial and 2 by 1. Canceling, 4 factorials cancel. I get those go away. We can continue further, and 2 into itself is 1, 2 into 6 is 3. My final answer, 3 by 5, which is 15. Right? Going on to number 6. All right. Okay. Go ahead and try the next one. Alright, I know some of you came up with the answer that this was undefined, but let me remind you of our definition. That is, when we have 0 factorial is 1. This is important for you to remember. So let's go back to the question at hand. Alright, so we have 8 factorial. Do remember 0 factorial is simply 1. The 8 factorials will cancel each other. So I end up 1 over 1, which is 1. Right? So please remember or note that 0 factorial is 1. Alright, I would like on your calculators, by the way, if we go back into math, on a probability, you will see number 4 is our factorial. And so let's go back again to the main screen. Let's clear everything. So if I wrote 0 and now again math, go over to probability, PROB. Now item 4 is our factorial. Press enter. 0 factorial is 1. If we looked at some of the, or number 5 with our previous one, 6 factorial, it's a little bit of a pain, in my opinion, to sometimes do the factorials on the calculator, because it just feels as if I am doing too much work. Let's go back, delete. I put in the wrong sign. I want to divide, and this time my denominator, I had 2 items in the denominator, 4 factorial and 2 factorial. So 4 and my factorial. So again, I go to math and go back to probability. Number 4 will give me the factorial. I'm multiplying that denominator by 2 factorial, which really is 1. So it's nice to know a few of them in your head, because this process of sometimes putting it in is a bit tedious, right? So we ended up with 15, and if I just minimize my calculator there, you will see indeed that we got 15. All right, so yes, you can do all of these on your calculator, but sometimes it is actually faster doing it on your in your head or by hand. All right, let's continue. And there, I promised at the beginning that we would be looking at or getting used to 2 new symbols. So let's look at the second symbol that we want to get used to, which, all right, so the second symbol is called the binomial coefficient. We'll put it all together shortly, but we're just getting used to the notation. And this binomial notation, it is written in the form parentheses NR. No, this is not a vector. When there's an alternative, which is this NCR, or on some calculator NCR. I'll soon bring up my calculator to show it. And we use this part is used in probability theory. And when it, oops, theory, can't spell there, G-O-R-T-H, right? And when we do it in probability theory, this is known as the combination, right, or combinatorics. And we will typically say N choose R, all right? But we're not going to be going in these review videos, we're not going to be going into probability theory, but in our classes, we will be doing that, all right? All right, what exactly does this mean? So we mathematicians will define what we call the binomial coefficient. And these binomial coefficient, this n and r, the definition is in terms of the factorial. So it is n factorial divided by r factorial. So the numerator is what's on top in the bracket. The denominator r factorial is on the bottom. And then we have a third term, this position on the denominator, n minus r factorial. All right. And in order to see what that is or what it looks like, if we again say something like 6 choose 2 or 6 2, then it is 6 factorial, 2 factorial, and 6 minus 2 factorial. 6 factorial, 2 factorial, evaluating is now simple. We have done something like this. In fact, let me go up. This was one of your questions. 6 factorial, 4 factorial, and 2 factorial. And so we have done it already. It's not something strange, right? As I go through, I may even state it, although we haven't or we won't be doing the probability theory where we come into this thing called combinations or combinatorics. Let me show you on your calculator, whoops, what we will get. So let's look again. Let's clear everything on our screen. And let's say if I wanted to do N2, then what we're saying that is 6, and then we'll go to our calculator, the math button, go back to probability, which is where you do find us using this factorial a lot. And we have 6n and 2. And once we press enter, it gives us a final answer without us having to do much work. But as I said, I do want you to go through and get used to the notation, play with it a little bit, because it will help you, especially for some of the lower numbers, be able to work things out quickly. All right, so let's go again. And as we go through, we could check using our calculator and see what's going on. All right, let's look at a few things. So if we have, let's do a simple enough one. We want to, using the notation here, so you may want to write this down on your book because we'll be using it a bit. I want you to evaluate a few items, or we're going to do this together. Evaluate 3 choose 0. Yes, as I mentioned before, I will oftentimes say or the words 3 choose 0 or a number choose R, n choose R, rather than binomial coefficient nr. just because I have been, or we do work with it in a probability way a bit. Right, so let's evaluate all of these things and see what we get. So using our notation, 3 choose 0, we would have 3 factorial, 0 factorial, 3 factorial. As we go through, the 3 factorials would cancel. I would have 1 over 1 because recall 0 factorial is 1. My final answer will be 1. Alright, let's look at the next one. 3, 1. And we see 3 factorial, 1 factorial. 3 minus 1, which would be 3 factorial, 1 factorial over 2 factorial. Alright, now we have to peel off from the numerator in order to get probably the larger of the 2 factorials. And now we can cancel, 2 factorials cancel each other, and we evaluate. So 3 over 1 factorial is simply 1, so we get a final answer of 3. And if we continue in this vein, oops, want to show something here, want to show the formula. And let's continue. 3 choose 2. We'd have 3 factorial, 2 factorial, 1 factorial. I hope you saw that I subtracted 3 minus 2, gave me 1. And if we look at this previous problem, it really is the same. The only thing is that the denominator, the factors have been turned around, but numbers are commutative, so we will end up with the same answer as before. So that will just be 3. And lastly, let's look at our 3 choose 3. And this was 3 factorial over 3 factorials. Those will be cancelling. Take the two numbers and subtract that, end up with 0 factorial. So 3 factorial, 3 factorial. Whoops, I didn't need to write that again. So in going about this, we can cancel 3 factorial. Will cancel itself. The 0 factorial, as we mentioned above, is 1. So we again see something similar, that these two are the same, while those two middle ones are the same. Alright, just some calculator work. Let's see. Recall that our n choose r. Whoops, this is the same. Oops, let me not write it that way. Let me do it exactly how your calculator shows it. Some of the regular scientific calculator will have the n on the upper part. Okay, so let's see what we have. And turning on our calculator, there we go. We can put in 3 math. Go to the probability region. We are looking at number 3 and C, and I'll choose 0. Can press enter. I got 1, which is exactly what we got here. Bringing that back, we can either, sometimes if you have the same thing, we can do second entry. It brings it back. I can edit, if you wish, what I had. So 3 choose 1. And I get 3. Gonna do that shortcut thing again. So second entry, and then I am just using my right and left arrows, or my left arrow really, to edit the changes that I want to make to that previous equation or previous entry. Alright, let's go again. Second entry. Again, let's go back in, and 3 choose 3, and I get 1. So exactly the same situation as we had before. 1, 3, 3, and 1. Alright, so let's clear those, and Let's take off the calculator for the time being. Okay. Alright, so we have now gotten used to the two notations. We will put them together and look at what we call the binomial or powers of binomials and where this notation comes in.